I'm Anton Sabev. I'm the CEO of a new startup called BitAction out of Silicon Valley. And we're here to unveil the solution of a problem that many of you may not suspect is a big problem for any peer-to-peer video solution and any peer-to-peer deployment on mobile devices. So to see if you need to waste your time and hear the rest of what I have to say, I'm going to ask a few questions. How many of you here planning to deploy WebRTC solutions are not going to deploy your solutions on mobile devices? Can I see by a show of hands, is anybody not planning to ever deploy on mobile devices? Not a single one that I can see. Did I miss anybody? Okay. WebRTC is, as we all know, has three pillars that it stands on. It has this standardized, easy-to-use API, which everyone can use in very small amount of code, utilize, create peer-to-peer video connections and other real-time connections very easily. There's also a powerful codec base and audio-video and security path to make this happen. And the third pillar is being actually able to communicate to other devices in order to transmit that information out there. When we talk about mobile devices, the situation is very different than what is observed on the general internet. When we have to connect through cellular carriers, we carry these devices around. We can't hope that they're always going to be connected to Wi-Fi. That's not what our smartphones are all about. That's not what our tablets are all about. So have you asked yourself, are you going to be able to use WebRTC when you're traveling, when you're using a cellular provider? The answer is generally yes, but the caveat is that when you do that, you have to actually relay all these connections to the services you provide through a server. And when you do that, it's usually the person or the company who provides the services that has to foot the bill. And the bills that we're looking at are, depending on what kind of information is being transmitted, something in the order of $1 per customer per year. So that means companies who plan to have about 10 million customers, they should be ready with their 10 million per year in order to make those services be maintainable and live. If they want to scale to billions, well, that's the bill we're looking at. So this is the problem we're here to solve, and we have a solution. Our solution addresses only the connectivity portion of the problem. You're not going to see any flashy videos. We have a solution that proves that you can connect a smart device running from a cellular network carrier to another cellular network carrier device, and you can do that directly without the need for any turn or any other type of relaying, which means this is a solution that can compete with the biggest and best peer-to-peer players nowadays, such as Skype. And in connectivity, I don't mean compete in a way of compete, but it is competitive in its technical features to that. And as an example, on the screen, you have displayed, many of you might have heard the numbers of you can connect in 86% of the cases with ICE and turn, and not connect in 14% of the cases and have to relay. But that is the case when you talk about the internet in general. When you're talking about mobile device usage, you're starting to see the picture on the screen, which is you get cut down to a quarter of the cases that you can connect a device to device, and 3/4 you need to relay. How many of you have a deployed audio-video solution of any kind that works off of mobile devices? I have 1, 2 people. And are you using churn or any kind of relaying for that? Stun? Yes. And is your solution working off of cellular networks? And in what country are you operating? In the United States. And does your solution work from behind AT&T? It does. Okay. So, all right, it's good to know that we have competition. So, I am going to show you a very brief demo which proves connectivity from T-Mobile to AT&T. I have a device in my hand that doesn't have Wi-Fi enabled. It's running entirely on a cellular carrier. And this device will run a quick app that is going to show our connectivity solution. And on the display, I'm going to display a backend server, which this is not going to be pretty. This is a server. It's supposed to be in a box and have no monitor. But this is the server that makes the signaling happen behind everything that's going on. And there's no relay of any sort involved. The connection that you're going to see is direct. So I'm going to start my client, which shows up on the server. It shows my name. And we also have, you can see there on the server, we have our software engineer, Alex, also on the server running a similar application. And also his phone is not connected on a Wi-Fi of any sort. It's connected through AT&T. And what we're going to do is Alex is going to call me from his phone from the same application. And I want to pay attention to how fast this connection is. How fast it's going to come through, how fast we're going to connect. Alex, could you give me a call, please? Here's the call, and I'm going to accept the call. Can you hear me, Alex? As I said, our audio is not what we're demonstrating. Alex, can you hear me?
Somewhat.
Somewhat, yes. But we did connect, and we did do it in about a second worth of time. And we're able to do it. But the most stunning thing about it is we're shutting down the server. I just shut down the server. The server is no longer running. There's nothing to relay the signal right now. It's going directly from this cellular phone to Alex's cellular phone in the other end of the room. And if this is put behind some very good echo cancellation, it will work with video stream through it. It will work very well for that. And this is what I believe is the missing piece for any audio or video solution that is hoping to make it maintain a large customer base. And you can see the server in red here, by the way, which, well, if you can see it, it's dead. If a solution needs to scale, if you want to maintain, let's say you have a super app and you're hoping to get 7 billion people on it, this is the solution that can do it on a small company budget. Not, so that's the goal of the solution. Now, I'm going to show you what we already saw, what connectivity looks before and after. And what I'd like you to pay attention to is the fact that using the BitJet 1 SDK, which is basically SDK for developers who want to add just the peer-to-peer functionality to their product, it doesn't address audio, video, or any other stuff. We are able to connect in the majority of the cases in the mobile environment, which means once you can connect in the majority, you can actually do relays not just on the server, you can assure peer relay. So your possibilities of where you can go with this technology are unlimited. In the cases that you can't connect in half the cases directly, there is no way to leverage off of other peers. There's no way to connect other peers through other peers. because you will have to ask the other peers to serve more than one connection, and it's, the bandwidth limitations are starting to kick in, and the system will not be smooth, and people just refuse to pay that kind of bills to relay connections for other people. You need this to be in a minority of the cases. This problem, and the way the problem will solve this through traversing symmetric NATs, and not just any symmetric NATs, but the most difficult and the most security cranked up symmetric NATs out there. And it's completely different than the way ICE and STUN go about this. Many people might have questions of, is this possible at all, and how does it work? All I have to mention is that it is possible, and the approach taken to solving this problem was cryptanalytic. And we have taken some methods used for breaking ciphers and used them to solve this problem. Many of you may recognize the face of our CTO, Whitfield Diffie, who is the co-inventor of public key cryptography. And he has been helping with this together with a very talented team of mathematicians. That's all I have to say. If anybody has any questions. Thank you.